Hello and welcome to this video where we're going to be looking at some more exam style questions that may come up in a GCSE style exam. This is a follow-on from my previous two videos looking at areas and volumes of shapes. So what I would say is if you haven't watched those yet, please go and watch those because you'll probably need some of the things that we've covered to be able to do what we're doing here. Right, let's do this. So in this video, we're going to look at some of the more, should we say, abstract type questions you may get, or multi-part questions rather. Usually what they'll do is they'll ask you a question looking at areas or volumes, and then there'll be some follow-on questions like the ones we'll cover in this video. So this question here is about calculating how many of something can you make from a piece of material. So these pins are manufactured from brass rod, which is available in 2-meter lengths. They're turned on a center lathe, and the parting tool used to remove the finished parts wastes 2 millimeters per component. So basically every time one of these gets cut off on a center lathe, if you don't know what that is, go and have a look on YouTube Shorts. Maybe I'll post one in the description. But basically every time one gets cut off, we lose 2 millimeters of material. So the question is, how many of these can be manufactured from a single 2-meter length of brass rod? And including the 2 millimeter offcuts, how much of each bar is wasted in millimeters? All right. So pause me now, go and have a go, see if you can do this. If not, then when we come back, we'll have a look at how it's done. All right, so hopefully you've had a go at doing this and have got to an answer. The answer is 19. So 19 components like this can be made from one 2-meter length of bar, and there's a total of 100 millimeters of material that is wasted. So effectively, per item, there's 102 millimeters that you have to take account for. So the 100 millimeters of the component itself, but also the 2 millimeter cut. So if you treat each one as a 102 millimeter piece, then what you can do is you can take the 2 meters, which is 2000 millimeters, divide that by 102, and that gives you an answer of 19.6. So obviously that's 19 complete components with 0.6 wasted. And then when you factor in all of the cuts as well, essentially you end up with 100 millimeters of material wasted. Okay. So the way you work this part out is obviously if you've got 19 of these being able to be cut out, that equals 1,900 millimeters. There's obviously 100 millimeters left that we're not able to use, whether that comes from the piece on the end that's left over or the cuts. Okay. All right, so that one hopefully was relatively straightforward. Let's have a look at a follow-on question from this. And like I say, they very often give you multi-part questions where you will have to calculate something and then use that to calculate something else. So let's have a look. So each of these bars costs £125. I've put that in to keep it relatively simple. When I looked up the price of brass, it was quite shocking. It's a lot more than this in real life, unfortunately. But let's assume for the case that we've got going on here, this example, that they are £125 each. So with that in mind, how much does one of these cost? So what is the material cost for each of the brass components? And then how much money does the wasted material cost the company? Obviously, they've still got to purchase the material in its full length. So when they make components like this, they will have to factor in the cost of the waste. Okay, right, it's that time again. So pause me, have a go, see if you can get to an answer. And when we come back, we will have the answers. Okie dokie, let's have a look then. So what have we got? The answer is £6.25 per component, and £6.25 of material is wasted. Now, if you think back to the last question, this second part here, you may not actually have needed to calculate because you know there's 100 millimeters being wasted from the previous question, and you know each of these is 100 millimeters long. So effectively, once you've calculated the answer for the first one, you've also got the answer for the second part here as well. And the way we did this, or the way I did this, was you take £125 and you divide that by 2,000 to work out the price per millimetre. So once I've got the price per millimetre, I just then multiply that by 100 to get the cost of this. Okay, so very often in questions like this, you'll need to follow exactly the same strategy of taking how long is the piece of material and take the price and divide it by that length to work out the price per millimetre before you then multiply it by how many millimetres you're interested in to get the answer. All right. Okay, let's move on. So that is a relatively straightforward one you may get in terms of the question isn't particularly complicated. There's only really one or two ways of doing it. If we look at this question here, this one's a bit different because it's not looking at a problem that can be solved in just one way. You may have to consider two different ways of doing this. So looking at this, a company wants to laser cut a set of components from offcuts of acrylic that it has in storage. The acrylic offcuts are 150 millimeters by 200 millimeters. So that's represented here. So 150 millimeters wide and 200 millimeters tall. The components they want to cut out of this are 30 millimeters by 40 millimeters. And here's a little picture here. So the question is, how many can they cut from that sheet? How many of those can they get out of that? All right. Now, we are going to look at the answers and how to do this in a second. But again, pause the video, have a go, and see what you get. And we'll be back in a sec. All right, so hopefully you've got an answer to this. Spoiler alert, the answer is 25. Okay, you can get 25 of those components out of that sheet. So let's have a look at why that is. Now, what I should have said before, and I didn't, is that when you do a question like this, you'll have to consider which way round you're going to try and fit these into this sheet, okay? And that does have an impact on how many you're going to be able to get out of it. Let's have a look at why that is. So if you lay them out vertically like this, you can see in my amazing animation that 25 will fit on this sheet. All right. If I lay them out the other way, like this, you can see that I don't get 25. In fact, I get 18 on here. And as you can see, there's not quite enough room over here to fit this one. This one does not fit, so we cannot have, look at that, amazing. We can't have another row down here, and also, sorry, another column down here, and we can't have another row down here. So on a question like this, if this comes up in an exam, you may have to calculate it both ways to work out which one is the most efficient, because it might not be like this where they really perfectly fit into the shape. It could be that in both scenarios there's a bit of waste, but actually in one of them you get more out. So how did I work this out? Let's have a look. So I've got the sheet of acrylic and I've got the component I want to cut out of it. So first thing I did was trying to work it out this way up. What I said was, right, so this is 30 millimeters wide and this is 150 millimeters across. How many of these can I fit widthways across here? Okay, so I did 150 divided by 30. How many 30s could go into 150? And I got the answer 5. It fit perfectly, not 5 point something, bang on 5, okay? Next I did exactly the same thing. So how many 40s can fit into the height of 200? So same thing, 200 divided by 40 gives me 5, which tells me that I can fit 5 horizontally and 5 vertically. So it's 5 by 5 or 5 multiplied by 5 to get how many fit, okay? And obviously 5 times 5 equals 25. So 25 can be cut out. Now, if we look at the same problem but from a different perspective, if we try and do it this way around, what we're doing this time is we're asking, okay, if I laid them out this way, how many of these 40 millimeter edges can fit into this 150 millimeter edge along here? How many can I lay out? So I do 150 divided by 40, tells me I can fit 3.75. So I can get 3 whole ones and 3/4 wasted at the end because there's a bit that won't fit. Same with the vertical. So how many of these 30s, so this edge here is 30, how many of those 30s will fit into that 200mm edge along there. So 200 divided by 30 equals 6.67. So 6 will fit and some waste as well at the end. Okay, so what this says is I can fit 3 horizontally, I can fit 6 vertically, and I can see here there is some waste. So we have 3 by 6 or 3 multiplied by 6, 3 times 6, which gives us 18. So that tells us that laying it out this way is much less efficient because there's wastage, whereas this one fits absolutely perfectly. I can get 5 by 5 with no decimals at the end here that represent waste. Okay, so that's how you would calculate. If a question asked you how many of those can fit into that, this is how we would do it. Okay, right, so I want to do one more, I think. This one, here we go. So those random pieces of plastic that we just looked at, they're being used to make a nightlight. The most amazing nightlight you've ever seen. So the company intends to produce a new model of rechargeable nightlight and would like to know how much a single product will cost to produce. So calculate the cost of a single nightlight. Okay, now this is a perfect example of one of these questions where the question is a follow-on from the previous. So to be able to do this properly, we're going to need, well, we're going to need the prices, but we're also going to need to know the answer to the previous question, because if you know, for example, that 25 of these little acrylic faceplates can be cut out of each one of the offcuts, you can then use that to calculate the cost per one of these. All right, so inside this amazing nightlight that I designed on Fusion, there are some components which are included here and all of the prices for them. So the faceplates, first of all, we need 2 of them, and the offcuts from the previous question cost £1 each. Okay, so to work out how much this is going to cost, we need to know, first of all, how many that we can cut out of one of the offcuts, and then we divide the cost per sheet by that number to work out how much one costs. And in this case, we need 2, so we need to double that for this. LED light units, so that's the lights here. There's 1 each side, so we'll need 2 of those, and they cost £1.50 for a bag of 10. The wooden frame, they are 30p each. The circuit board is 50p, and the battery is £6 for a pack of 10. Whereas the connectors that connect the batteries to the circuit board, they are £3 for a pack of 20. All right. So to answer this question, what you're going to need to do is work out per one of these lights how much is each of these things going to cost. So you're going to have to do a bit of dividing. If you would like to pause me now and see if you can work out what the answer is to this question, how much is one of these going to cost, we'll be back in a sec with the answer. Okay, here we go then. Ready for the big reveal. Boom, look at that. £1.93 is the answer, if I have done my maths correctly. There is a slight chance I haven't, but I think I have. So £1.93, and let's go through and work out why. So the faceplates, we know that we can fit 25 out of, or we can cut 25 rather, out of one of the offcuts. So if they are £1 each, well, £1 divided by 25 is 4p, and I need 2. So that's a grand total of 8p in acrylic faceplates. Next, the LED light units. They're £1.50 for a bag of 10. So if we take £1.50 and divide that by 10, it works out as 15p each. And again, we need 2 of them. So that is 30p in LED lights. The wooden frame, we don't need to do any calculation there. Circuit board, nothing there. We just use these numbers. The battery, £6 for a pack of 10. Well, if I take £6 and divide that by 10, I get 60p. And for the battery connectors, they are £3 for a pack of 20. So these are 15p each. If you take £3 and divide that by 20, you get 15p, and we only need 1. So if you add all those together, boom, this is what you get, £1.93. Now, hopefully, you've been taking notes as we've gone through this. Please say you have. what I would say is, if you haven't, maybe just skip back through the video and make a couple of sort of flashcards, revision flashcards on these things, because these are, with the 2 other videos we've looked at already, these are the kinds of questions that you will get in a GCSE paper. I can't think of any others that we would have, apart from perhaps looking at Ohm's law, but I'll do a video on that separately at a later date. All right, so that is it, and that is it for the maths ones for now. So next time we'll be moving on to look at something else. I can't remember what it is. I have made a plan. But yeah, please like and subscribe. That would help me out a lot. Thank you very much. Bye-bye.